What's inside a ship's gyrocompass? The brain behind the ship's heading. Welcome aboard, Ship's Tech Talk. Today, we're unlocking the secrets inside one of the most important navigation instruments on any ship, the gyrocompass. We'll be opening the world-famous on-chute standard 22NX gyrocompass to reveal what's hidden inside, how it works, and why no modern vessel can sail without it. From high-speed gyroscopes to precision electronics and fluid balancing systems, this small sphere is what keeps your ship pointing toward true north anywhere on Earth. Stay tuned till the end as we explore both the common and uncommon engineering wonders inside this powerful piece of marine technology. What is a gyrocompass and why ships depend on it? A gyrocompass is unlike a magnetic compass. Instead of detecting the Earth's magnetic field, it relies on the principles of gyroscopic inertia, gravity, and Earth's rotation to find true north. This makes it far more stable and reliable, especially in areas with magnetic disturbances or near the poles. On a ship's bridge, the gyrocompass acts as the navigation brain, feeding accurate heading data to autopilots, radars, ECDIS displays, and steering systems. Without it, ships would lose their sense of true direction in seconds. How does it find true north? Once powered on, the gyrocompass enters its heating phase, stabilizing the temperature of the liquid and gyrosphere. Next, it enters the settling phase, where the spinning gyroscopes interact with Earth's rotation. Over time, the axis of rotation naturally aligns with the Earth's meridian, pointing toward true north. The system's internal sensors and algorithms then make fine corrections for latitude and ship speed, delivering a stable and precise heading output, usually within 0.1 degree accuracy. The gyrosphere. At the center of the gyrocompass lies the gyrosphere, a perfectly balanced sphere that houses two high-speed gyroscopes, spinning at an astonishing 12,000 revolutions per minute. This tremendous rotational speed gives the gyrosphere incredible stability, allowing it to resist the rolling and pitching of the ship while maintaining its orientation toward true north. The gyroscopes are powered by a 400 Hz, 3-phase, 55-volt alternating current electrical supply, which keeps the rotor spinning at a precise and consistent speed. This high-frequency power minimizes vibration and ensures smooth, continuous operation even under the most demanding sea conditions. Now here's the fascinating part. 400 Hz, 2-phase, 55 volts alternating current electrical power generated from the gyrocompass's power supply PCBs is transmitted to gyroscopes through the upper and lower calottes of the gyrosphere and even through the supporting liquid itself. The third phase required for the spinning gyros is generated within the gyrosphere using capacitors. This clever method eliminates the need for mechanical slip rings, allowing completely sealed electrical transmission. It keeps the system maintenance-free, avoids wear, and ensures perfect isolation between the rotating gyroscope and the static outer housing. The outer sphere. Surrounding the gyrosphere is the outer sphere, a strong, hermetically sealed metal casing that provides both physical protection and environmental stability. It shields the sensitive gyroscope from shocks, vibrations, and sudden temperature changes that are common on board ships. This outer sphere contains both distilled water and a special supporting liquid, which helps to suspend, cool, and stabilize the gyrosphere in its operating position. Distilled water and supporting liquid. Inside the outer sphere, two mixed fluids play crucial roles: distilled water and a supporting liquid. The distilled water maintains purity, preventing the buildup of minerals or contaminants that could cause corrosion or interference. The supporting liquid, a specially formulated damping fluid, supports the gyrosphere almost weightlessly, minimizing friction and mechanical resistance. Together, they act as shock absorbers, thermal regulators, and electrical conductors, assisting in both physical stability and the transfer of electrical energy. The system constantly monitors the temperature of this liquid. If it exceeds 60 degrees Celsius, the gyrocompass triggers an automatic high-temperature warning to protect the internal components. The equatorial band. One of the most important yet often overlooked components inside the gyrocompass is the equatorial band. This band is positioned around the equator of the gyrosphere and plays a unique role in the system. When the spinning gyros align with the meridian, the gyrosphere rotates along with them. The extent of this rotation is measured by the processing PCB, which determines the ship's current heading in relation to true north. The equatorial band is crucial for measuring the gyrosphere's rotation. The processing PCB detects changes in resistance between 2 points on the equatorial band of the gyrosphere and the outer sphere. This information is then converted to indicate the ship's heading with respect to true north. The pendulum joint. Deep inside the gyro housing lies the pendulum joint, a small but ingenious mechanical feature that ensures the gyrosphere stays aligned with gravity. As the ship changes latitude or sails across rough seas, the pendulum joint makes micro-adjustments, compensating for Earth's curvature and tilt. This allows the gyro to remain level and maintain true north alignment even during prolonged voyages across different hemispheres. Without it, the compass would slowly drift from accuracy. The pump. Within the gyro housing, a miniature circulating pump continuously moves the supporting liquid. This circulation prevents the formation of air bubbles and distributes heat evenly. Specifically, the fluid motion generated by the pumps keeps the gyrosphere suspended, preventing it from resting on the bottom of the outer sphere and ensuring consistent damping conditions. The result is exceptional heading stability and long-term performance, even after thousands of operational hours. The pump ensures that the internal environment remains calm, balanced, and perfectly conditioned for precision navigation. Power supply and the electronic brain. Modern gyrocompasses, like the Anschutz Standard 22NX, rely on intelligent electronics to process and distribute data. The internal printed circuit boards regulate the 24-volt DC power supply, generate the 400 Hz 55-volt AC drive signal for the gyroscope, and handle all control and monitoring functions. They also measure liquid temperature, rotation speed, and heading output, ensuring the system stays fully calibrated at all times. These PCBs output heading data via Ethernet, CAN bus, and NMEA connections, seamlessly linking the gyrocompass with other bridge systems, such as radar, autopilot, and ECDIS. This integration makes the gyrocompass not just a compass, but the central navigation hub of the ship. Applications across the marine industry. The gyrocompass is the most important navigational aid across all ship types, from commercial cargo ships and tankers to naval vessels and research ships. It provides heading data for autopilots for course control, radar and ECDIS systems for chart alignment, dynamic positioning systems, and bridge alert management systems for safety and monitoring. Its modular, IMO-compliant design allows multiple gyro repeaters, heading sensors, and GPS systems to integrate seamlessly, ensuring continuous navigation reliability even if one component fails. Uncommon facts you didn't know. The gyroscopes spin at 12,000 RPM, powered by a 400 Hz, 3-phase, 55-volt alternating current electrical supply. Electrical power is transmitted through the upper and lower calottes and via the supporting liquid, eliminating slip rings and mechanical wear. The settling time is around 3 hours. However, there is a quick settling mode that reduces settling time to 1 hour with an error of 3 degrees. The gyro's liquid circulation and self-heating system allow it to function reliably between -15 degrees Celsius and +60 degrees Celsius. Continuous monitoring by intelligent PCBs ensures full self-diagnosis, fault alerts, and data integrity 24/7. So, what's really inside a gyrocompass? A small, spinning miracle, the gyrosphere, powered by high-frequency electricity, floating in a liquid world, and guided by the physics of Earth's rotation. The gyrocompass is a perfect blend of mechanical precision and electronic intelligence, an unsung hero that silently keeps your ship on its true course through the world's oceans. If you enjoyed this deep dive into the engineering behind the gyrocompass, don't forget to like, share, and subscribe to Ship's Tech Talk for more fascinating stories about ship technology, machinery, and life at sea. Hit the bell icon and stay tuned for our next voyage into maritime innovation.